and in this module, we go reactive. What does go reactive mean exactly? It means programming with a focus on data streams. So instead of reading data into an array and then binding to that array, we work with observables and bind to those observables. By working with observables, we leverage the many operators available in Ngrx3. We transform, compose, and combine streams to better manage multiple data sources. And we define action streams to easily react to user or application actions. We're going reactive for the remainder of this course, and we'll see how going reactive improves performance, handles state, reacts to user actions, and simplifies our code. This module covers techniques and best practices for retrieving and displaying data using a more reactive approach. We begin with the async pipe, look at handling errors, and implement a more performant change detection strategy. We then walk through a declarative pattern for data retrieval that better leverages the power of observable streams. The Ngrx3 features covered in this module include catch error, the empty constant, and throw error. Before we get started, let's set up the sample application we'll use throughout the remainder of this course. In this course, we want to stay focused on Ngrx3, not on building components and templates. So I've created starter files with the basic application structure and components in place. Find the files here. The APM Start folder contains the starter files for coding along with the demos. If you want to code along, clone the repository, or if you're new to GitHub, simply click this button to download all the code as a zip file and unzip it. Then rename the APM Start folder to just APM. With that, we're ready to set up the sample application. Open the APM folder in your favorite editor. I'm using VS Code. Select Terminal, New Terminal. Sometimes the terminal prompt doesn't appear. If that happens, press Enter. Then type npm install to install the application libraries. This installs all of the packages defined in the package.json file. This application is comprised of several key features that are organized into folders under src/app. The Home folder contains the application's welcome page. The Product Categories folder contains the files for retrieving product categories. The Products folder contains the code for the product features. This includes a service to manage the data retrieval and components and templates for the feature pages. The Shared folder contains the shared module for pulling in modules or components used by multiple features. And the Suppliers folder contains the code for the supplier features. This includes a service to retrieve supplier information. Now that the install is complete, let's run the application. Type npm start to open the application in the browser. Welcome to Acme Product Management. As its name implies, this application manages our company's current list of products and the suppliers we order those products from. You may have seen this application in other courses, such as Angular Getting Started, Angular Reactive Forms, and Angular Routing. In this implementation, we have two styles of user interface to demonstrate several Ngrx3 techniques. The product list page displays a list of products. We use a simple UI here to focus on the reactive patterns used to manage application state. When we implement it later in this course, the drop-down will provide a filter for the list, and clicking Add Product will add a hard-coded product to the list, demonstrating how to add items to our observable streams. We'll use the product list alternate UI to examine additional Ngrx3 patterns. It provides a condensed list of products. When we implement it later, clicking a product will provide notification of the selected product, and we'll see the product detail. The detail includes both product information and the product's suppliers, illustrating how to combine streams from multiple data sources. Going back to the code, let's open the Products folder and take a quick look at the procedural pattern it uses to retrieve data and display that data in the product list page. We'll improve this pattern throughout this module. When retrieving data, our first step is to define the shape of the data. We do that here in the product.ts file. We use an interface to define each field we are expecting in the retrieved data. The question mark identifies any optional fields that may or may not exist in that retrieved data. These are sometimes called nullable fields. In the product service, we define a method to get the list of products. We use our defined interface here to specify the type returned by this method, and here, so the HTTP GET method automatically maps to that shape. It uses a pipe to pipe the response through a set of operators, including tap to display some debugging information, and catch error to handle errors. We'll talk more about error handling shortly. In the product list component, we inject the product service in the constructor, then use the on-init lifecycle hook to call the service getProducts method each time the page is initialized. We subscribe to start the observable, which issues the HTTP GET request. When we receive the HTTP response in the service, our observer is notified, the next method is executed, and the observable completes. In the next method, we assign a local products property to the product array returned in the response. If an error occurs, here we assign a local error message property to the returned error. In the onDestroy lifecycle hook, we ensure the observable stream is stopped when the page is destroyed by unsubscribing. Unsubscribing could get complex as we add more observables to the application. There are techniques to help manage the lifecycle of our observables, but we could simplify this code if we let Angular handle our subscriptions for us. More on that shortly. In the product list template, we use an ngIf directive to ensure we have products before attempting to display the table. And here we use the ngFor directive to loop through each product in the products array and display it in a row of the table. That's the basics of the pattern that is often used to retrieve data. Now let's look at how to make this code more reactive, starting with the async pipe. We access an observable directly in a template using the async pipe. The async pipe automatically subscribes to the observable when the component is initialized. It returns each emitted value from that observable. When a new item is emitted, the component is marked to be checked for changes and runs change detection, modifying the UI as needed. This makes the async pipe a key part of our reactive development strategy. And the async pipe automatically unsubscribes when the component is destroyed to avoid potential memory leaks. How do we change our code to use an async pipe? Using the async pipe does not require a change to our service code, only our component and template. Here is our current product list component, implemented using the common data retrieval pattern. And here it is, a little more reactive. We start by replacing the product array with the observable of product array. By convention, we add a $sign to the variable name to indicate that it is an observable and not a simple array. Then, since the async pipe handles our subscription, we no longer need to subscribe in our component code. We simply assign the observable returned from the service getProducts method to our observable property. That looks a bit cleaner already. Here is our current product list template bound to the products array here and here. Now that we have an observable property indicated with the $sign, we pipe it through the async pipe to access its emitted values. This automatically subscribes for us and handles unsubscribing. We use the as clause to assign each emitted item to a variable we use in other places in the template. So products $is the observable, and products is the array of products emitted from that observable. We use the products variable here as we iterate through, displaying each product in the template. No other changes are required. Let's give it a try. Here in the product list component, since the async pipe handles the subscription, we can delete the code that subscribes. Notice this deletes our error handling. We can also delete the assignment. We can delete the code that unsubscribes, so we no longer need to implement onDestroy. And we'll delete the unused variable and our unused imports. Next, we change our declaration from a product array to an observable of product array and append a dollar to the property name to indicate it's now an observable. Use the quick fix to import the observable type from Ngrx3. We assign this new property to the observable returned by the getProducts call. Now that we have an observable property in our component, we can use the async pipe in our template. In the product list template, change the ngIf to use our observable property and pipe it through the async pipe into a products variable. We're already using that variable here, so that's it. Let's see if it still works. Bring up the browser, click Product List, and we still see our list of products, so all is well. Looking back at the product list component, recall that we deleted our error handling. Let's fix that. In real-world applications, we need to handle errors. When working with observables, it's important to catch errors. Recall from earlier in this course that any error stops the observable stream. It won't emit any more items. That means once an observable stream has an error, we can't use it anymore. There are two basic strategies for handling errors with observables: catch and replace, and catch and rethrow. In both cases, the first step is to catch the error. That brings us to our next operator. The catch error operator catches any errors that occur on an observable. Here we catch the error and pass in a handle error method for processing the error. Note that the catch error operator must be sequentially after any operator that could generate an error. Use catch error for catching errors and rethrowing an error, or replacing the errored observable with a new observable so we can continue through our pipeline after an error occurs. Let's examine the catch and replace strategy first. The catch and replace strategy involves catching the error and replacing the errored observable with a new observable. What do we replace the errored observable with? Depending on the error in the observable, we could return an observable created from hard-coded data or data stored locally for the user. For example, if the application uses local storage to store a list of items, the stored list could be used if an error occurs retrieving the current list of items. We could return an observable that emits an empty value or empty array. Or we could return empty, which is an Ngrx3 constant defining an observable that emits no items and immediately completes. We'll talk more about empty in the next clip. In this example, we catch the error and log it to the console. In a real-world application, we'd log it to a server somewhere, but this works for our purposes. If the observable has an error, it stops and won't emit any more items. So we create a new observable and return it, effectively replacing the errored observable. In this example, we use the ofCreation function to emit a default array of products. In a real application, if a retrieve is unsuccessful, we may fall back to a locally safe set of items or return an empty set. The observer does not get notified of the error because the catch error caught and handled it. Instead, the observer's next method is called with the emitted array from the new observable. The marble diagram for catch error looks like this. On a marble diagram, an error is depicted with an X. Here, our source observable generates an error. The catch error operator catches the error and creates a new observable, which emits the array of two products. That array is emitted to the result stream, and processing continues as if there were no error. More formally, catch error is an error handling operator. Just like every other operator, it takes an observable stream as an input, subscribes to it, and creates an output stream. When an item is emitted from the input stream, it's emitted to the output stream. If there is no error, catch error outputs a stream identical to its input stream. If an error occurs, catch error catches the error, unsubscribes from the input stream, and returns a replacement observable. It optionally rethrows the error, propagating it further up the chain. We've just talked through the replacement strategy. Now let's look at how to rethrow the error. We examined the catch and replace strategy for error handling, where we catch the error with the catch error operator and replace the errored observable with a new observable. An alternate strategy is to catch and rethrow. In this example, we again catch the error with the catch error operator and log it. Once an observable has an error, it stops and won't emit any more items. We use throw error to return a replacement observable and rethrow the error, propagating it further up the chain. Wait a minute. Did I just say that throw error returns a replacement observable? Throw error is actually a creation function that creates an observable that emits no items and immediately emits an error notification. Here we throw the specified error. Use throw error to propagate an error to other parts of the application. More formally, throw error is a creation function that creates and returns a replacement observable that emits no items. Its return value is represented as observable of never because it emits no values and never completes. After creating the observable, throw error immediately emits an error notification, stopping the newly created observable. In our existing service code, our common pattern for handling errors uses the catch error operator to catch any errors that occur when retrieving data. In this example, we use the catch and rethrow technique. We call the HTTP GET method and catch any errors by piping the resulting data through the catch error operator. In this case, we pass in the name of an error function. The handle error function executes some code to log the error and build a user-friendly error message. We'll see more of this method in a moment. The throw error replaces the original observable with observable of never, and then emits an error, essentially rethrowing. Since the service rethrows the error, it's up to the component to catch that error. Our original component code used the subscribe to provide an error method. We set the local error message property there. But now that we've changed to a more reactive development approach, we aren't subscribing. We instead catch the error propagated from the service by piping the emitted item through the catch error operator, like this. In the catch error, we set the local error message property to the error message propagated by the service. But then what? We have to follow our catch and replace or catch and rethrow error handling strategies. We don't want to rethrow from our component because the error will propagate to our template. We'll instead catch and replace. If, due to the error, we don't get data from our service, our component may want to replace the errored observable with an empty observable. That brings us to our next RxJS feature, empty. Empty is an RxJS constant that returns an observable that emits no items and immediately emits a complete notification. Here we return empty. Use empty to return an empty observable. It is especially useful when replacing an errored observable when you have no default value or to catch and ignore the error. In our error handling, then, we replace the errored observable by returning empty. Now let's see error handling in action. In this demo, we add error handling to our application. Looking at the product service, we are already using the catch error operator with the catch and rethrow strategy. If an error occurs, we call the handle error method. In the handle error method, we build a custom error message and then use throw error to propagate the error to the component. In the product list component, we want to catch any errors thrown from the service, so we pipe the observable through the catch error operator. Use the quick fix to import catch error. The catch error operator function takes in the error. We'll assign any returned error message to our error message property. But we have a syntax error. What is this saying? It's telling us that we aren't returning an appropriate observable. Recall from the slides that in our component, we need to follow the catch and replace error handling strategy. We already have the catch. We need to add code to replace the observable. First, we convert the one-line arrow function to a multi-line function by adding curly braces. We then need a semicolon to end each statement. After we catch the error and assign the error message, we replace the observable with a new one. If we have an error, we have no products, so we could return an observable that emits an empty array. Note that we need the return keyword since we now have a multi-line arrow function. That fixes our type error. Alternatively, we could use the empty Ngrx3 constant and use the quick fix to add the needed import. Let's see if our error handling works. Bring up the browser, click on the product list option, and open the developer tools. Here we see the logging when the data is retrieved from the backend server. Note that we are using the Angular in-memory web API. This lets us mock a backend server so we don't have to set one up. But that means we won't see our requests and responses in the Network tab. That's why it's useful to use the tap operator to display the retrieved data in the console. To try out the error handling, back in the code, in the product service, change the URL so it's not valid. I'll delete the S. Going back to the browser, we see our error message both in the UI and in the console. Our error handling works. In a real-world application, we may want to display a more detailed error message, providing information on the issue and what the user should do to resolve it. But this makes the point for our purposes. Going back to the code, let's change the URL back to a valid value. Viewing the browser, all is well. Now that we're working with observable streams and have implemented the async pipe and error handling, let's revisit the why. Why would we use a stream with an async pipe over just binding to the emitted array? Benefits to using a stream with an async pipe. There is no need to subscribe. The async pipe handles our subscriptions for us. And that leads to the next benefit. No need to unsubscribe, so we don't have to manage our subscriptions. With the async pipe, we also have the option to improve performance by modifying our change detection. Let's talk a bit more about this last one. Angular uses change detection to track changes to the application's data structures, so it knows when to update bound elements in the UI with changed data. Change detection ensures our template bindings display the current data from our component. There are two basic change detection strategies. Default uses the default check always strategy. Every component is checked when any change is detected. On push improves performance by minimizing change detection cycles. With on push, the component is only checked for changes when input properties change, an event emits, or the one that matters in our case, when an observable emits, if that observable is bound in the template using an async pipe. Using the async pipe, we are now binding to an observable, so we can use the on-push strategy and minimize change detection cycles. This can improve display performance. We set the change detection strategy as part of the component decorator. Let's turn on push change detection. In the product list component, we set the change detection strategy here in the component decorator. Use the quick fix to add the import, and that's it. Looking at the browser, the data appears as expected. The performance impact isn't noticeable unless we are working with more UI elements. Looking back at the component code, notice our error message property. Now that we are using the on-push change detection strategy, we can't just set a bound property and expect it to update in the user interface. Change detection won't notice the change. Let's again modify the URL in the service to generate an error. Looking at the browser, we see the error in the console, but don't see the error message in the UI. By changing to the on-push change detection strategy, our UI won't update unless an observable emits another item. We'll see how to turn our simple error message property into an observable stream a little later in this course. For now, let's be sure to fix the URL in our service. Using the async pipe, our code is more reactive. But could we do better?
Inside that is a child 3 with the location of C. And then we also have as part of the view on the child component. Location A is another instance of child 3. Now this one never gets selected, but it's just kind of here to show you that nothing selects this, nothing goes into child component 2 and looks at its view. So location A is never selected. Close it out to get it out of the way. The code itself, pretty straightforward. We're using view children. Children by default is going to look at descendants. Okay, so you see that when we get into it. We have a couple different options for content children. Sometimes with descendants set to true, and sometimes with descendants not set to true. Down the bottom here, we just have some code that runs and it takes a look at what we get in the query list. We'll take a look at query list in more detail. Actually, next part of the course, and we'll take a look at that in just a few minutes. So it goes through the different output from my selectors. It just sets a variable that determines whether it gets put up on the screen. So jumping back over to the browser, you can see
Practices for data retrieval begins by defining the shape of the expected data using an interface or a class. Next, we build a service to encapsulate the HTTP code that submits requests to and processes responses from a backend server. Using a Following best practices for data retrieval begins by defining the shape of the expected data using an interface or a class. Next, we build a service to encapsulate the HTTP code that submits requests to and processes responses from a backend server. Using a declarative approach, we set a service property to the observable returned from HTTP GET. We set the type argument so HTTP client can automatically map the response to the desired shape. When the response is received, the return data is emitted and the observable completes. We pipe the return data through any required operators, minimally the catch error operator. In a component, we assign the property defined in the service to a local observable property. We then bind that local observable property in our template. For improved performance, use on-push change detection. We can use on-push because we are binding to an observable that is notified when changes occur. In the template, use the async pipe to subscribe, process each emitted item from the observable, and unsubscribe. Use the as syntax to map each emitted item into a property we can use in the template. There are two key techniques for handling errors when working with observables. The catch and replace strategy involves catching the error with catch error and replacing the errored observable with a new observable. Use this strategy when you want to capture the error and continue. The replacement can be an observable that emits an alternate set of data stored locally or hard-coded in the application, an observable that emits an empty set, such as an empty array, or the empty constant, which is an observable that emits no items and immediately emits a complete notification. Alternatively, use catch and rethrow. This strategy involves catching the error with catch error and rethrowing the error with throw error. Use this strategy when you want to propagate an error, such as from a service to a component. Catch error catches any error and replaces the error observable with a new observable. It is often good practice to catch the error at the source to log it, so your team can more readily resolve issues. Then rethrow it and catch it in the component so you can notify the user of the issue. Be sure to transform any technical error message to user-friendly messages for display. Throw error creates an observable that emits no items and then immediately emits an error notification, stopping the created stream. Use it to propagate an error. Now that we know how to retrieve data using reactive techniques, let's look at how to map that data to our needs. Sometimes the data